All right, so problem 4.17. I'm going to solve this using the universal method. So I'm going to go ahead and label this node ground. So we know this node is 160 volts. This is our first unknown. Second unknown, and then third unknown node. All right, so we have, I forgot what the name for that symbol is. So I'm gonna call it I naught. Let's go ahead and call this IS. And then we're gonna call this I1. So we have a KCL. And it's IS plus I naught equals I1. And then we have an ESC. We're going to call, say IS is equal to 160 minus V1 over 10. It's an ugly. All right. Then we can say I naught is equal to 0 minus V1 over 100. We have I1, V1 minus V2 over 30. Then we know that V2 minus V3 is equal to 150 times I naught. So we have 1, 2, 3, 4. Okay. Oh, and we also know, right, that I1 is also equal to V3 minus 0. Yeah, over 20. V3 over 20 is I1. Right. So we have 1, 2, 3, 4, 5. So missing 1. Yeah, so we have six missing variables. So we have 6 equations. 1, 2, 3, 4, 5, 6. All right, and let's plug this into the calculator to maximum. I love using this calculator. It makes things much easier. I mean, at the end of the day, you can do the math. It just saves you time. Anyone can solve these linear equations. I1 equals V1 2 over 30. Minus V3 equals 150 times I naught. Yeah, V1, V2, or let's start with the S, I naught, I1, V1, 2, V3. All right, so here we go. So copy and paste this. So this is what we get from maximum, right? So I naught is -1 amp. So in reality, the current is moving in the opposite direction. It's moving this way. So the problem is asking us to calculate the power delivered by the dependent voltage source, right? Okay, so we know that the voltage here in this dependent voltage source is 100 times -1, negative 150 volts. So that's the potential, the negative potential, right? So says the power delivered. So we know the current I1 is passing through that, so we can just say power, I'm going to call it DS, say negative 150 times I1 is 5. So 150 times 5 is negative 150 watts. And this should be our answer.